Welcome to all of you in Sankalpa Education Pratham classes. I am Sachin Patil, delivered lecture series on derivative or differentiation. Right now we are going with the derivative of inverse trigonometric functions, and the examples depends upon the following formulas. That means sin inverse x is equal to cosec inverse 1 divided by x. We have to think that in a different way. That means you can perform it in this way, because we have to convert this formula inside this formula, and you want to find out the derivative of that one. First of all, we have to require to taking the derivative of cosec inverse x, cosec inverse, and after that you have to use the 1 divided by x. To find out the derivative of 1 divided by x, we have to use the derivative of division of two functions, and which is required more and more time. We have to further see that how it required a different time or different consideration. And for this purpose, first of all, we have to get these derivative functions, nothing but cosec inverse 1 divided by x is equal to sin inverse x. Sin inverse 1 divided by x is nothing but a cosec inverse x. Sec inverse 1 divided by x is nothing but a cos inverse x. Cos inverse 1 divided by x is nothing but a sec inverse x. Cot inverse 1 divided by x is nothing but a tan inverse x. And tan inverse 1 divided by x is nothing but a cot inverse x. I am reading those formulae in reverse direction, because we can't convert those formula inside those formula. You have to convert those formula inside this one, because if you convert this formula into this one and you want to find out the derivative, first of all we have to going with the derivative of tan inverse, then we have to use the rule of division, derivative of division of two functions here, and which is a tedious job and requires some efforts related to that one. Now we are going with the derivative of following functions by using that one. First of all, we have to get the consideration of let y is equal to cot inverse 1 divided by x square is here, and by using the formula of cot inverse 1 divided by x is equal to tan inverse x. That means you have to take the reciprocal of this one is here, and therefore y is equal to tan inverse x square is here. Right now we have to use the regular formula related to tan inverse x square is here, and it is nothing but a inverse trigonometric composite function. And by using inverse trigonometric composite function, this is the f of x, and therefore you have to get the derivative of y with respect to x is nothing but a dy by dx is equal to 1 divided by, we know that the tan inverse having the derivative, we cover this x square by your finger and find out the derivative of tan inverse x is tan inverse x having the derivative 1 divided by 1 plus x square. That means x is here, at that time you will use the x square, that means 1 divided by 1 plus x square raised to 2 and into derivative of ddx of that x square is here, and therefore 1 divided by 1 plus x raised to 4 into x square having derivative 2x, and therefore you will get the answer is 2x divided by 1 plus x raised to 4 is here, and this is the derivative of that function. Similarly, you can perform the derivative of tan inverse 1 divided by log x is here, tan inverse 1 divided by log x, tan inverse 1 divided by x is here, tan inverse 1 divided by x having the derivative cot inverse x. That means you have to reciprocal that here, and therefore you will get the consideration of let y is equal to tan inverse 1 divided by log x, and we have to use the formula y is equal to cot inverse log x. And right now the derivative of cot inverse x, we know that the derivative of cot inverse x, therefore y is the function of x, therefore derivative of y with respect to x is dy by dx is nothing but a minus 1 divided by 1 plus x square, but here x square is nothing but a log x, and therefore x is nothing but a log x, and therefore you will get the log x square is here into ddx of that log x, ddx of log x, and therefore minus 1 divided by 1 plus log x square into derivative of that one is nothing but a x, and therefore minus 1 divided by x into 1 plus log x square, and this is your derivative of that function is here, right? Similarly, you can perform the derivative of those functions which is related to sec inverse 1 divided by root x is here. Let us consider, let y is equal to sec inverse 1 divided by root x. Sec inverse 1 divided by root x. Once again, we know that the sec inverse 1 divided by x, sec inverse 1 divided by x is nothing but the cos inverse x. That means you have to take the reciprocal of that one here, and therefore by using this formula you will get the consideration of y is equal to cos inverse root x. Once again, we cover the root x, and we know that the derivative of cos inverse x is nothing but what? The derivative of cos inverse x is minus 1 divided by square root of 1 minus x square, and therefore you will get the consideration of dy by dx is equal to minus 1 divided by square root of 1 minus root x square here, and therefore minus 1 divided by square root of 1 minus root x square is x, and therefore this is the derivative of that sec inverse 1 divided by root x. Similarly, you can find out the derivative of cosec inverse 1 divided by sin x is here. Cosec inverse 1 divided by sin x. First of all, we have to know that consideration of cosec inverse 1 divided by x is nothing but a sine inverse x. That means you have to take the reciprocal of 1 divided by x is here, and therefore you will get the consideration of or also you can find out the consideration of 1 divided by 1 divided by sine is equal to cosec, and therefore by using the consideration directly here, first of all we have to carry out the consideration by using 1 divided by sine x is nothing but a 1 divided by sine x is nothing but a cosec x, and by using that when you will get the considerations related to that one. First of all, we have to going with the formula, and formula is here. Let y is equal to, I am using that space, y is equal to cosec inverse 1 divided by sine x, and therefore according to formula cosec you will get the sine inverse sine x is here, and you will get the consideration of y is equal to sine and sine cancel to each other, x is here, and y is the function of x, derivative of dy by dx is equal to 1 is here. Right now we can also solve this by using 1 divided by sine x formula. We know that the 1 divided by sine theta is equal to cosec theta, and by using this one you can calculate the consideration of this one is nothing but a let y is equal to cosec inverse cosec x, cosec inverse cosec x is here, and cosec and cosec cancel to each other, y is equal to x. Therefore y is the function of x, there we have to take the derivative of y with respect to x, dy by dx is equal to 1 is here. We know that the considerations of those one, and how to use those formulae in reverse direction. One thing is here, I want to find out the derivative of that function, this function cot inverse 1 divided by x square, by using a regular method, and what are the differentiations, what are the consideration related to that one is taken here. First of all, I am considered those formulae in those direction, and right now we have to use those formulae in a reverse direction, and we have to use those in a forward direction right now, and by using those consideration we can find out the derivative, how it is required the efforts to find out those derivatives is seen in next example related to that one. Now we have to consider those formulae in forward direction. For this purpose, first of all we have to take the consideration of that tan inverse x square function, and we know that it is directly having the derivative. Later consider it is done by using y is equal to tan inverse x square is here, and we know that we cover the x square expression by our finger, and we know that the derivative of tan inverse x is nothing but a dy by dx is equal to 1 divided by 1 plus x square raised to 2 is here into d dx of that x square, and therefore derivative of that one is nothing but a 1 divided by 1 plus x raised to 4 into 2x. That means 2x divided by 1 plus x raised to 4. Right now we have to we know that I'm first of all said that we have to use those formulae in a reverse direction, because this formula is converted into this one and you will get the less efforts related to that one. We have to convert this formula into this one, then you will get the lot of efforts related to that one. Now we have to going with the tan inverse x, and you will get the cot inverse 1 divided by x. By using this formula you have to get the consideration of y is equal to tan inverse x square. Right now we have to convert, we have to use this formula in a forward direction. That means tan inverse x is equal to cot inverse 1 divided by x. Then you have to get the consideration of cot inverse 1 divided by x square. 1 divided by x square. Right now we have to cover this 1 divided by x square by your finger and find out the derivative of cot inverse. What is the derivative of cot inverse? Cot inverse x having the derivative minus 1 divided by 1 plus x square, and therefore you will get the consideration of derivative of y with respect to x, dy by dx is equal to minus 1 divided by 1 plus 1 divided by x square raised to 2 is here into d dx of this 1 divided by x square is here. And first of all we have to simplify that one. You will get the minus 1 divided by 1 plus 1 divided by x raised to 4 into d dx of 1 divided by x square is here. D dx of 1 divided by x square is here. And then you will get the consideration, then simplify this one by making denominator same by using this cross multiplication is here, and you will get the consideration minus 1 divided by x raised to 4 plus 1 divided by x raised to 4 into d dx of 1 divided by x square. Now this x raised to 4 is taken, x raised to 4 divided by x raised to 4 plus 1 into, now we have to find out the derivative of this one by using a derivative of u divided by v. That means a division algebra, and at that time you know that the denominator is the x square. First of all we have to use the denominator as it is and taking the derivative of numerator, that means 1 minus numerator as it is and taking the derivative of denominator, that is x square, and divide by square of the denominator, x raised to 2, x square raised to 2 is here, and therefore you will get the minus x raised to 4 divided by, I just reverse this one, because 2 plus 3 is equal to also 5 and 3 plus 2 is equal to also 5, and therefore 1 plus x square x raised to 4 into x square, derivative of 1 is 0, and therefore x square into 0 minus derivative of this 2x is here divided by x raised to 4 inside the denominator, and therefore you will get the minus x raised to 4 divided by 1 plus x raised to 4 into minus 2x divided by x raised to 4. This x raised to 4 and this x raised to 4 cancel to each other, and minus into minus you will get the plus 2x divided by 1 plus x raised to 4. You will get the same derivatives are here. We will get the same derivatives are here, but this required a lot of efforts and this required very small efforts here. And if you if there will be any denominator consideration, at that time you will use those formulae in a reverse direction, not in forward direction. If you use this formula in forward direction, at that time you will require a lot of efforts to solve that same derivative by using that forward direction formula of it, and you will get the small efforts to find out the derivative when it is used in a reverse direction. And therefore you first of all use the formula in a reverse direction and find out the derivative. If you like that video, please subscribe my channel and press on bell icon to get the next notification related to lecture series of derivative. Thank you.